We'll proceed in vector summation and integral calculus. Vector summation and integral calculus, the arena in which we are proceeding mind-blowing discussion. Mind-blowing discussion. Okay, what is the summation of 1 square plus 2 square plus 3 square plus plus? I was seeing it. In algebra, it is, I believe it is n into n plus 1 into, into 2n plus 1, something like that, divided by 6. This has to come to research now. Means x into x plus 1 into 2x plus 1 divided by 6. Anyway, we are in phase of calculating the bank interest where a person has deposited y0 money in the account and then someone else is depositing. There is a fixed deposit in bank. And when there is a fixed deposit in bank, if person has deposited y0 amount, y bottom right small 0 as a subscript, means money that is deposited at 0 time, y0. Money at any moment in a fixed deposit in a bank is y0 into e to the power ct, where it is going through continuous compounding interest. Continuous compounding interest means probably we can take 1 day. For 1 day, what is the interest? And then at the end of the day, principal and interest will get clubbed together, and that will become principal for the next day. Every day, compound interest happen. If C is the interest rate per year, then per day interest will be C by 365. Okay, then we saw that if I have a fixed deposit account in bank and I am receiving and it is for compounding interest, then every year at the end of year someone else is depositing S money in the account. Next year end S money in the account. Next year end S money in the account. This is what keep on happening. So Y0 money in the account, it is getting interest every year. And then every year, end of the year, S money is being external money that is being deposited in the account. It can be considered, loosely it can be considered as if I have an electronic circuit, then I have a voltage source outside. I have a voltage source outside if I have an electronic circuit. Okay, that is means S is the voltage source outside and it is getting added every year. Then we saw then the calculation that comes at the end of T years, how much money someone can expect in the fixed deposit account. Then it will be y0, y in the bracket T, y as a function of T, or someone can write y bottom right as a subscript small t means y at the end of t year how much it is equal to y0 at the beginning how much he has deposited e to the power ct plus s money is being deposited in the account fixed deposit account every year s. So it will become S and in bracket e to the power c in bracket t minus 1 plus e to the power c in bracket t minus 2 plus e to the power c in bracket t minus 3 plus e to the power e to the power c bracket t minus t e to the power 0 e to the power 1. It will be 1. So it is y0 e to the power ct plus s and in bracket e to the power ct e to the power c in bracket t minus x, where x goes from 1 to t. Someone has to find summation of x goes from 1 to t e to the power c t minus x. That is the question. If I have an expression e to the power c, e to the power c t, e to the power c, c in bracket t minus x, e to the power c in bracket t minus x, where this is a function, e to the power c t minus x is a function. I can say fx, function over x, where this function is getting sampled At x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. Like that, it is getting sampled at different x. Okay, so it will become e to the power c t minus 1 plus e to the power c t minus 2 plus e to the power c t minus 3, like that e to the power c t minus t. Or I can write it as also summation, sigma sign, summation x equal to 1 to small t e to the power c t minus x. That is the that someone has to calculate. Okay, now to alleviate this calculation, we we have invented two ways to calculate repeated, two way to calculate addition. If someone has a full-fledged addition, e to the power c t minus 1 plus e to the power c t minus 2 plus e to the power c bracket t minus 3 plus e to the power c in bracket t minus t, this full addition, if someone has to do, we can divide this into t different parts because we have to add for t times t different part where each part is e to the power c t minus x. This is what I can say. If I am saying part number 1, then I have e to the power c t minus 1. Part number 2, e to the power c t minus 2. Part number 3, e to the power c t minus 3. Like that. Part number t, e to the power c t minus t. Now I have done part by part. Break problem into t different part and different part. Now each part, now the aim is each part make it same. If I want to make each part same, then first part is e to the power c t minus 1. Second part is e to the power c t minus 2. How both will become same? Then it is e to the power c t minus x. All will become e to the power c t minus x. If I have to add e to the power c t minus x t times, I can add it for x time. This is the rule number 1. What is rule number 1? First, divide into n different parts, then part by part start tackling it. Then make sure that each part looks same. Introduce one independent variable x out there. And then we have e to the power c t minus x t times. Make it x time e to the power c in bracket t minus x time, if I add how much it will be, into x into dx. Summation from x is 0 to small t. If someone does, he will come to one solution. Another solution is successive approximation. Successive approximation says that if I have summation x equal to 1 to t fx, where fx is e to the power c t minus x, means if I have a fx. Okay, consider consider this is x-axis. This is x-axis. If I have a fx, then fx is like this. This is x-axis. This is fx, and fx is e to the power ct minus x. Okay, if this is e to the power ct minus x, I have summation x equal to 1 to summation x equal to 1 to t fx e to the power c t minus x, where x will go 1, 2, 3, 4 summation. This summation I have to find out through integral calculus. If I am trying to find out through integral calculus, if this is the fx e to the power ct minus x, then it has verticals at x equal to 1, x equal to 2, x equal to 3, x equal to 4. If I try to solve this adding all the verticals through integral calculus, then I have another function called gx. Consider there is another function called gx, and I'm trying to calculate gx dx. Gx dx means what is the area underneath gx, that is gx dx. Okay, if I divide this area into t different parts, okay, where x is 1 and x is t, I divide this full area into t different parts. If I take one part, then if it is fx, if this is gx, this height is gx, multiplied by the gap between these two parts, where x is 1, x is x and x is x plus 1. This gap will give the area sub area. If I add all this sub area underneath gx, it will become gx dx. X is from lower limit to higher limit. Similarly, I have another function called fx, fx gx. Okay, is there any way I can show fx gx? Okay, this is x-axis, and consider this is this is fx. This is x-axis, this is fx, and this is gx. If this is gx, if I take any point here called x, then this is the height. This height is e to the power c t minus x. This is the height. If I talk about gx, then gx is the height from here and it will touch here. Okay, if I talk about fx, then this is the height. This height, fx, if I talk about our actual problem, then I have to add all the heights. Whereas if I try to achieve through integral calculus gx, then I have to calculate underneath area. If I take any x, then I have fx as height. That should be equivalent to, for any x, whatever height I get in gx multiplied by the next width of the next sampling. If I do, then one fx height will be same as gx dx for this substrip area. Add all the sub area, it will become gx dx. Same as I add all the vertical line. Now for one vertical line, I'll try to, the concept is I have to find a continuous function called gx. If I'm able to find a continuous function gx, then gx dx from lower limit to higher limit should be exactly same as summation x equal to 1, that is lower limit to higher limit, sigma x equal to lower limit to higher limit fx should be exactly same as integral lower limit to higher limit gx dx. I have to find gx because fx I know, e to the power c t minus x. Okay, limit I know, x is going from 1 to t, sorry 0 to t. Here gx dx, I know limit is going, x is 0 to t, gx, but I don't know gx. I have to find gx. If I am able to find gx, I can solve the problem. Okay, we will go with the simpler case and then we will try to find the solution. Then we will come to this. Now we have already seen how we can calculate summation of something called 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus 8 square, like that. If someone is trying to calculate like this, if someone is trying to calculate like this, what will be the algebraic equation? 1 square plus 2 square plus 3 square plus 4 square up to anything, up to x square. If someone is trying to calculate this, then how it is possible? Okay, then what we saw, I have what I am trying to do, summation x equal to 1 sigma sign x equal to 1 to n times, or summation x equal to 1 to x fx is x square, means 1 square plus 2 square plus 3 square up to x square. This is what need to be calculated. Okay, now it should be same as integral gx dx, where dx will go from dx will go from 1. Dx will go from 1 to x. This is what I think so. dx will go from dx will go from 1 to dx will go from 1 to x. Dx will go from 1 to x. Makes sense? I think it really makes sense. Okay. Zero will go from 1 to x. Okay, I'll try with the, I believe it is all right. Okay, I'm doing fx dx. I'm sorry, summation x equal to 1, summation x equal to 1 to x, and then fx. Fx is x square. If I'm trying to calculate x square, fx is x square. Fx, I'm sorry, fx is x square. Okay, if fx is x square, then how I can calculate integration from lower limit to higher limit gx dx. Okay, this is also called successive approximation. Through successive approximation, what we will try is we will take x-axis. At x-axis, I'll take any point x, any point x. At any point x, this is the fx. What is the height? What This is fx. Means what is the sampling height at any point x? This is fx. What is the point if I take another continuous wave called gx? Then this is the height called gx. But gx dx will give the area where fx is sampled at different point. At any point x, what is the sampling height? It should be exactly same as. If someone is watching minutely, at x equal to 1, 2, 3, 4, 5, 6, this is what I have sampled. And we are getting verticals. We are getting verticals. Okay, one vertical should be exactly same as if I talk about f gx. Then at that x, what is the vertical of gx? And then next sampling of fx. Between this, what is the gap? If I multiply, I get the sub area in gx. That sub area should be exactly same as the height in fx. Now, if I go to next x, then this is the height in fx. That should be exactly same as the sub area in gx. So I take any term x and try to equate it. If I get a reasonable solution, then I have cracked the gx. Then I have cracked the gx. Okay, that is the concept that we are pursuing. We have already calculated this. Okay, now let's try it. At any point x, what is fx? Then it is e to the power ct minus x. If I talk about x square, then it is x square. X square equal to, what is the area of sub area? X to x plus 1. That is x to x plus 1. F gx dx. Dx dx. X to x plus 1 dx dx should be equal to fx x square. At x, what is the height? Height should be exactly same as what is the area strip in the gx. Okay, if I say fx equal to gx dx, then gx equal to fx by dx, or dfx by dx. Okay, in that fashion, the fx is x square. We have done it in the past. Let's try little different. Let's try little different. What is little different? Let's add 1 square plus 1.5 square. Okay, so let's try 1 square plus 1.5 square plus 2 square plus 2.5 square plus 3 square plus 3.5 square plus 4 square plus 4.5 square, like this. I have not seen this solution up till anything. 1 square plus 1.5 square plus 2 square plus 2.5 square, like this. What is fx? Fx is x square only. Now I am trying to find gx. Fx equal to integration gx dx, where gx I have to find as a continuous function. That is called gx. Okay, if I try in this manner, then fx is x square. X square, if I take x equal to x, please watch our previous two videos. So if I take any point x, then fx is this. Whereas if I take gx, then at x, height is gx multiplied by the gap. Gap between two sampling is 0.5. So 0.5, this area, sub area should be exactly same as fx. Okay, that is the case. Means fx is going like this and gx is going like this. So this is what we will try. If we try this fashion, then we have some a limit sign x to x plus 1 by 2. that is the sub area with x to x plus 1 by 2. Gx dx should be exactly same as fx, that is x square. I believe it is alright. That is x square. Now we will try. Initial moment looks like fx equal to gx dx. Gx equal to dfx by dx. That is 2x. We'll try with the 2x. 2x dx. X to x plus 1 by 2. 2x dx. 2x integration will be x square by 2. X to x plus 1 by 2. If I set it, then it will become x plus 1 by 2 whole square. We had taken 2x square by 2, x square. X square limit is x to x plus half. That will become x plus 1 by 2 whole square minus x square. That will become x square plus x plus 1 by 4 minus x square. It will come in x and some constant. This is certainly not what we want. We want it should come to x square. We will try with the x square only. If I try with the x square, if I try with the x square, then x square integration is x to the power 3 by 3. Limit is x to x plus 1 by 2. If I set it, then it will become x plus 1 by 2 whole square to the power 3 minus x to the power 3 by 3. If I settle down the first one, x to the power 3 plus 3 into x square into 1 by 2 plus 3x into 1 by 4 plus 1 by 2 to the power 3, 1 by 8, whole by 3 minus x to the power 3 by 3. X to the power 3, 3 will go away. Now 3x square into 1 by 2 by 3 will become x square into 1 by 2. X square into 1 by 2 plus it will become 3 by 3, again it will go away, x into 1 by 4 plus 1 by 8 into 1 by 3. Makes sense? If I take x square, then it will be 1 by 8 into 1 by 3. 1 by 24. This is how it is. Now, if I see the then minus x to the power 3 by 3. So, first x to the power 3 by 3 will go away. Okay, what will remain now? Remain is 3x square into 1 by 2 by 3. That will become 1 by 2x square. 1 by 2x square. 1 by 2x square plus something. Okay, plus something x plus something constant. We have got 1 by 2x square. Here we want x square. Means whatever we have done till now, we have to multiply by 2. We'll try again. We tried with the x square dx. We'll try with 2x square dx multiplied by 2. Now settle it down. 2 outside x to the power 3 by 3. 2 by 3 into x to the power 3, where I have to do minus of x plus 1 by 2 to the power 3 minus x to the power 3. Now we have outside waiting 2 by 3, and inside will become 3x square into 1 by 2 plus 3x 1 by 4 plus 1 by 8 minus x to the power x to the power 3, x to the power 3 will go away. If I settle it down, then it will become just x square into 1 by 2 and outside 2 by 3, 3x square into 1 by 2. Outside 2 by 3 will go as x square, just x square plus 3 will go away. It was x into 1 by 4. It will become x by 2, x square plus x by 2 plus 2 by 24. So whole will become, if I integrate 2x square, limit x to x plus 1 by 2, it will become it would become x square plus x by 2 plus 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 2 by 24. Now we have x square, but now what we are getting now? X square, exactly x square we are getting. Extra we are getting now. What extra we are getting is x by 2 plus 2 by 24, 1 by 2, 1 by 12. x by 2 plus 1 by 12, we are getting extra. Let's settle down x by 2 now. X by 2 now. Okay, let's settle down x by 2. If I settle down x by 2, we started with the previous one was 2x square. 2x square. 2x square minus x. Just I'll do minus x and let's see what will come. Okay, 2x square minus x. We'll try again. Okay, 2x square integration will be 2x to the power 3 by 3 minus x integration will be x square by 2. 2 by 3 x to the power 3 will get settled down at x by 2 at x by 2 x square, that is matching one, that is what we want. Extra thing will be x square plus 1 by 12. This is what we have seen. X by 2 plus 1 by 12 minus 1 by 2. And in bracket we have x plus half whole square minus x square. It will come as x plus 1 by 4. X plus 1 by 4. X plus 1 by 4, outside I have waiting 1 by 2, minus 1 by 2, minus x by 2, minus 1 by 8. X by 2 will go away. Now we have 1 by 12 minus 1 by 8. Okay, it should become 0. To make it 0, I have to add 1 by 12 minus 1 by 8. Means 1 by 12 is less. I have to add something. Okay, if I do go with the same, then it will become 2 by 24. It will become 3 by 24. I have to add by 1 by 24. If I add by 1 by 24, it should become same. We'll try again. Okay, we started with 2x square minus x plus 1 by 24. 1 by 2 will be extra plus 1 by 12. We'll try now. Okay, 2x square. 2x square. Makes sense? 2x square minus x plus 1 by what I want. I want 1 by 24. So plus 1 by 12. If I settle it down, the first two terms will fix each other, and what remaining is 1 by 12 minus 1 by 8. This is what we have seen. And this side 1 by 12 x. X is x plus half minus x, 1 by 2, 1 by 24. So 1 by 12 minus 1 by 8 plus 1 by 24 will become 24. 2 minus 3 plus 1, 0. Means we got the solution. If someone is trying to add 1 square plus 1 and a half square plus 2 square plus 2 and a half square to anything, then I have to integrate a function called gx. 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 Okay, gx. And for gx, if I'm trying to go for gx, then what is gx? gx is gx is 2x square minus x plus 1 by 12. This is gx. It will really give the result. We'll try now. Let's integrate it. 2x square will become 2x to the power 3 by 3 minus 2x to the power 3 by 3 minus x square by 2 plus 1 by 12x. This is what is the algebraic equation that will give the result. Okay, now I have to place limit if I am trying to calculate where the limit will go. Limit, if people are watching the past video, there we had set limit x to x plus 1. Here we have set limit x to x plus 1 by 2. So there we have to settle it down by adding 1. Here we will settle it down by adding 1 by 2 plus 1 by 2. What I'm trying to say is what we have got right now. We have got now gx is 2x square minus x plus 1 by 12 dx. Limit is 0 to x, because this is how we have to add. Limit is 0 to x. Okay, but as per the experience, if it is half is sampling, then I have to go both for 0 to x plus 1 by 2. Okay, then it will become the integration what we are talking. The integration what we are talking is 2 by 3 into x to the power 3 minus 1 by 2 into x square plus 1 by 12 into x. Now I have to place 0 to x plus 1 by 2. Someone can try 0 to x. Then it will become like this only. Then someone can try. Let's try. Let's add 1 and a half, 1 square plus 1 and a half square plus 2 square plus 2 and a half square plus 3 square. How much it will be? 1 square, 2 square, 3 square will become 9 plus 4 plus 1, 14. 1 and a half square will become 2.25. 2 and a half square will become 6.25. Then it will become 8.5 plus 14, 22.5. 22.5. If I place there x equal to 0 to 3, then how much it will be? Okay, if I place 3 there, 2 by 3 into x to the power 3. 2 by 3 into x to the power 3. That will become 9 into 2 as 18 minus x minus 3. That will be 15. So far less than what we are thinking. 22.5 is the expectation. Okay, so we will go by, if in the beginning limit, if people remember, in the beginning limit, we had tried x to x plus half. So we'll try here 0 to x and half. So if I'm trying to add from 1 to 3, then I'll try the limit from 0 to 3 and half. Okay, let's try now. 2 by 3 into x to the power 3 minus x square by 2 plus 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 1 by 12x. Okay, let's place 3.5 here, that is 7 by 2. If I place 7 by 2, what I am trying to say, instead of x, I have to replace it by x plus 1 by 2. Okay, this is called successive approximation. We have to do approximation successively, step by step. So now replace x with the x plus 1 by 2, half gap. So it will become 2 by 3 x plus 1 by 2 to the power 3 plus x plus 1 by 2 whole square by 2 plus 1 by 12 into x plus 1 by 2. Now limit is 0 to x, same limit we will put. Now limit is 3, so 3 will become 3 and a half. So 2 by 3 into 3 and a half to the power 3 minus 2 minus 3 and a half whole square by 2 plus 3 and a half by 12. Okay, how much is 3 and a half to the power 3? If someone is calculating 3 and a half to the power 3, what is 3 and a half whole square? 3 and a half whole square is 3 plus 0.5 whole square. 9 plus 0.25 plus 0.25 plus 3, 12.25. It will become 12.25. 12.25 into 3.5. Okay, it will become 36 plus 6, 42. 42 and some change. 42 and some change. 42 into 2 by 3, that will come as 80, 84. Some change, let's make it some change. Then let's make it, it will come around 84 plus some, let's make it 85, 80, 86, 86 by 3. 86 by 3, how much it will come? Okay, 2 around 29. 86 by 3 will come 29. 29 minus 3.5 whole square by 2. That will come as 12 by 2, 6 minus 6. Minus 6 point some change. So 29 minus 6 will come as 22 plus some change. That is 3.5 by 3.5 by 12. Okay, plus some change. I believe it will come as some quarter. So it will come as 22 and quarter or something more like that. To 22.5 around it will come. Okay, then it will, the exact solution is 22.5. Our solution is 22 point something. It is nearly. If now let's try, someone has to try because I cannot do that much. So let's we what solution we are getting? 2 by 3 into x plus 1 by 2 wholes to the power 3. X plus 1 by 2 to the power 3 into 2 by 3 minus x plus 1 by 2 whole square by 2 plus x plus 1 by 2 by 12. This is what we are trying. Person can try keeping x from 0 to 4. This is he can try. And let's see what is the difference someone is getting in the actual result and when he plays x equal to 3. If the difference is, if difference, consider the difference is alpha. And then someone is trying 0 to 4, difference is alpha. He is trying 0 to 5, difference is alpha again. This proves that at the end, I have to subtract with alpha. Alpha. Now that will come as a perfect solution. Can someone believe us? Through integral calculus, we can find any summation result that will be exact result. Or at the end, we did from 0 to x. Rather than I can do it 1 to x and try 1 to x. If I do 1 to x, then how much it will then the subtraction will be constant. Makes sense? Subtraction will be constant. 1 to x is variable, what 1 is constant because we started with the 1. How much is the subtraction? 2 by 3 into 1. 2 by 3 into 1 is 2 by 3 minus 1 by 2. X square by 2 is 1 by 2. 2 by 3 minus 1 by 2. How much it will come? Plus 1 by 12. If I take 12 as denominator, then 2 by 3, 4 I have to multiply. It will become 8. Top will become 8. 8 and then we have 1 by 2. 12 I have taken, then 4. We have 1, 6. 6. 8 minus 6 makes sense. 8 minus 6 plus 1. 8 minus 6 plus 1. That will come as 1 by 12. Means I have to subtract whole stuff, whatever we are getting with 0 to x. 0 to x, whatever we are getting, we have to subtract with 1 by 12 and see what the result is coming. Do the successive approximation till you come to a result, and then that is what we are looking for. What is 1 by 4 is 0.25. 1 by 12 will be, it will be very less. Anyway, how, what will be if I start from 0.5, then 2 by 3 into x cube. 2 by 3 into x cube, 1 by 8. 2 by 3 into 1 by 8 minus 1 by 8. X square by 2, that will come as 1 by 8 plus 1 by 24. Okay, if I take, the first is 2 by 3 into 1 by 8, 2 by 24. 2 by 24 minus 3 by 24 plus 1 by 24. So 2 minus 3 plus 1, that will become 0 whatsoever. Okay, person has to try this, all whatever I have said, and see what is the fixed alpha that I need to add or subtract so that it will become a kind of something that someone can rely upon. And then he gets the algebraic equation as 3 by 2 by 3x plus 1 by 2 whole square, 1 by 2 to the power 3 minus x plus 1 by 2 whole square by 2 plus x plus 1 by 2 by 12 plus some alpha or minus some alpha. Okay, if there is an alpha, this becomes a concrete solution to whatever we said. 1 square plus 1 by 2 whole square plus 1 by plus 2 square. 1 square plus 1 and a half whole square plus 2 square plus 1 2 and a half whole square. Like that, someone will get. Someone can try 1 square plus 1 and quarter whole square plus 1 and a half whole square plus 1 and 3/4 whole square plus 2 square plus 2 and quarter whole square plus 2 and a half whole square plus 2 and 3/4 whole square plus 3 square plus like that. Someone can try. What here is required is x square. At the beginning, it will be, earlier it was x square equal to summation limit x to x plus half dx. It will become x to x plus quarter dx and start the successive approximation. Can someone try 1 by 2 plus 1 by 3 plus 1 by 4, 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus like this. Can someone try with the successive approximation? Is it possible? That is a question mark. 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus. Someone has to try. Mind blowing this. What is required here? Fx is 1 by x and gx will be x to x plus 1 because it is going, this is x axis, and if I have a fx, sampling is going at x equal to 1, 2, 3, 4. Makes sense? Now, when x is 1, it is function is 1 by x, 1 by 1, 1 by 2, 1 by 3. These are the heights. 1 by 1, 1 by 2, 1 by 3, 1 by 4. Like that. So 1 by x equal to limit x to x plus 1 gx dx. Now someone can start gx dx and he has to come to a pure gx, then integrate gx dx, come to an algebraic equation, set 0 to x and get a pure algebraic equation, do some approximation and come to a result, and that will be the exact solution. Mind blowing, amazing. We can use indeed integral calculus to find the solution. Someone has to try it. This is something that is new to the world. No one has thought about it. No one has thought about it. Anyway, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Someone can work more on it.